Okay, you should have the worksheet that you received in class when we go through this information about the metric system. When we look at the metric system, the first thing we want to remember is how there's a base unit, and from that base unit, we have smaller units and we have bigger units. And if we have our main sections, the metric system is really bigger than this. If we have our main section of units in front of us, where we start with kilo and then hecto and then deca, and then our base unit and then deci, centi, and milli, we can talk about what the prefixes mean, okay? And milli means 1/1000th of, okay? And centi means 1/100th of something. Deci means 1/10 of, that's what this means, deci. We have our base unit. And then deca means 10 times, and hecto means 100 times, and kilo means 1,000 times that base unit. So we've got our units going from left to right, larger to smaller. And when they're all in front of us like this, we can really look at them and say a lot of different things about it. For example, we could say there are 10 millimeters in a centimeter. There are 10 centimeters in a decimeter. There are 10 decimeters in a meter. There are 10 meters in a decameter. There's 10 decameters in a hectometer or hectometer. And there are 10 hectometers in a kilometer. Each time we move from the right to the left, 10 of the smaller unit make up the next size unit, 10 of them. Okay? Now, if you think about that, if there's 10 millimeters in a centimeter, and then there's 10 centimeters in a decimeter, what you can really start thinking about is how you could skip a spot, okay? And you could go from here to here. And that would mean that there's 100, because 10 times 10 is 100. So there's actually 100 millimeters in a decimeter. You skip a spot. There's 100 centimeters in a meter, which should make sense because centi means 1/100th of. So there's 100 centimeters in a meter. If I pick the decimeter and I skip a spot, there's 100 decimeters in a decameter. If I pick the meter and I skip one place, there's 100 meters in a hectometer. Well, that makes sense because the prefix hecto means 100 times that base unit. Now, if I take the decameter, which is really one we hardly ever use, and I look next to it, but I skip one, there's 100 decameters in a kilometer. So you can almost kind of play a lot of games about the relationships that are in this chart. If I take the millimeter unit, which is the smallest one, okay, and I skip 2 places, make that green. If I skip 2 places, well, 10 times 10 times 10 times 10 is 1,000. So there's 1,000 millimeters in a meter. Well, that makes sense because that's what the milli prefix means, 1/1000th of. If I look at the centimeters and I skip 2 places and I talk about the decameter, there's 1,000 centimeters in a decameter. And if I take this decimeter and I skip 2 places, there's 1,000 decimeters in a hectometer. And if I take my base unit and I skip 2 places, there's 1,000 meters in a kilometer. Well, that one should make some sense because that's what the prefix 1,000 means. Now, we don't need to get all caught up in that. And remember, some of us aren't that mathy, so that just made you feel really uncomfortable, but don't worry about that. But the whole point that I'm making is when we go to the unit next door, there's 10 of the smaller one in that next biggest one. And if you have that in your mind, you can do this work, okay? Sometimes it's helpful to just be a little bit familiar with what these units actually mean. A kilometer is a little bit more than half a mile. We use miles here in our country, so we don't really talk a lot about kilometers unless you're in track and you run the 5K, which is 5 kilometers, or the 10K, which is 10 kilometers. Then you're pretty familiar with what that is. A cubic millimeter, which is a millimeter on each side, is really a small thing. This is a photograph of an eye pressure monitor that they can put in people's eye that monitors the pressure. And look, it fits right on the end of a penny. That's pretty small. So millimeters are pretty small. We're going to work with this section of the metric system that goes from kilometer to millimeter, okay? And I learned once, actually from a student, a memory device to put those in order. And what I was taught was King Midas had many daring awesome men. My dear mother called me Monday morning. That just gets all of these prefixes in order. You can work with anything. As long as you have the chart in front of you, you can do what we're about to do. But if you want a way to memorize them, come up with a nice memory device. Make up another saying. King Midas had many daring awesome men. My dear mother called me Monday morning is just one that I learned. So if we have this in front of us, and on your sheet, there's some blank spots. So right now, you should write in the ones that are not written in yours so that you have all the prefixes right in front of you. It's at the top of the page. Make sure you write those in so that you can see your prefixes in the right order. MM is millimeter, CM is centimeter, and etc. So again, each prefix has a meaning, okay? And the meaning of the milli prefix is that it is 1/1000th of something. It's 1/1000th, okay? That might be something that's good to write in your notes somewhere. Centi, what does it mean? It's 1/100th of. Deci means 1/10 of. And what is it always referring to? It's referring to this base unit. So a decimeter is 1/10 of a meter. A centimeter is 1/10 of a 1/100th, sorry, of a meter. A millimeter is 1/1000th of a meter. And then with our larger unit, deca means 10 times that meter. Hecto means 100 times that meter. And kilo, by definition, means 1,000 times that meter. Sometimes it's nice to just be able to think about how do I take a millimeter and convert it directly to the meter, okay? And one way to do it is a mathy way where you would actually multiply your millimeters by 0.001. You'd multiply your base unit by 1. If you were talking about centimeters, you'd multiply it by 0.01. But there's other ways to think about it and other ways that are a lot less mathy. When I look at my chart, we can see that, okay? Again, just to have those in order from right to left is very useful. And now, let me go back, we look back. Your device might help. Now, one of the things that we do is that we use a method called dimensional analysis, and it's based on what's called a conversion factor. Forth here a minute. I want to talk about the relationship between a kilometer and a meter. Okay, well, by definition, a kilometer is 1,000 times a meter. So by definition, there's 1,000 meters, that's equal to 1 kilometer. And when we have two things that are equal to each other like that, we can express them in a fraction form like this. So we can do a math way to answer this question. How many meters are in 7.25 kilometers? We'd start out with what they give us, 7.25 kilometers. And then we'd put that equivalency statement in the form of a ratio because there's 1,000 meters in 1 kilometer. And then these kilometers cancel like x's. And if we take 7.25 and we multiply by 1,000, then we would get 7,250 meters. And that works, okay? And that's a method that you're going to learn to solve problems with soon, very soon. But when we have the metric system chart right in front of us, the way we have on this sheet, there is an easier way, okay? And that way is to just look at our chart. Look at our chart. Oh, I need this to go away. How do I get rid of it? I'm having a problem with my technology. So be patient with me. Just like if I was there with you. So if we look at our chart and we can see all of it, and we want to know how many meters is equal to 7.25 kilometer, we're going to look at the chart at the part that we want to know, and that's why I put a little smiley face there, and we're going to look at the part of the chart that we started with, which is kilometers. I put a green mark there because green means go. And then what I'm going to do is I'm just going to count how many places over on my chart I need to move to get to meters. So it's 1, 2, 3. And if I move my decimal point 3 places, 1, 2, 3, I had to add a 0 for that third one, then I have the answer. And it's just a matter of moving the decimal over while I'm looking at the chart. It's really pretty easy. Make sure on your paper you filled out the prefixes so you have all of those in front of you. If you didn't, you can stop this video right here and do that. This is what your worksheet looks like. So let's do a couple of these together. All we're going to do is work with the method in which we use that chart and we move the decimal. So for number 1, I have kilometers, okay, that's here, and I want meters, that's here. So how many times would I need to move the decimal to change kilometers into meters? Well, I'm going to go 1, see I'm starting at kilometers, 1, 2, 3, 3 places to the right. I'm going to do the same thing with the number there. I've got 35. I'm going to move the decimal 3 places to the right. 1, I'm going to add a 0 for that. 2, add a 0 for that. And 3, I'm adding a 0 for that. Get my placeholder in. Now, interestingly enough, this has 2 significant figures, so I want to express my answer with 2 significant figures. I really don't want to mess that up. So if you get really excited and you put the decimal in after you move the decimal, you did some really good things, but if we want to keep our significant figures the same, what we're going to do is just call that 35,000, 35000. We're not going to show the decimal because now we have two significant figures before we converted it and two significant figures after we converted it. Make that go away. So let's look at the second one. We have 2,509 millimeters. This is what we're starting with, and we want to convert that to meters. So we're going to move the decimal in the same direction that we would have to move on the chart to get from millimeters to meters. One, two, three places. Again, I started here. 1, 2, 3 places to my left gets me to meters. So I'm going to take the decimal that's there, which it's invisible, but it's at the end. Okay. And I'm going to move the decimal to the left. 1, 2, 3. So when I do that, 1, 2, 3, I'm going to get 2.509 as my answer. And there it is. Okay, we had 4 significant figures before, we have 4 significant figures now. That hasn't changed. Clean up my workspace a little bit. Okay, let's look at the next one. Try that one without me. So we have 75.09 centimeters. We want to move it into units of millimeters. So I'm starting with centimeters. I'm going to move directly over to millimeters. That's on the left in my chart. So that's what I'm going to do with my decimal point. I'm going to move it one place to the left. So I have 75.09. I'm going to move that decimal one place to the left, and I'm going to get 750.9. And I just moved my decimal over one time. And that doesn't really feel mathy at all. So for those of you who don't like to be mathy, this isn't too bad. Let's look at the next one. Pause and try to do it without me. So we have 12.008 hectometers. So we're going to start here, and we want to move that to centimeters over here. How many times am I going to move the decimal to my right? 1, 2, 3, 4. Again, I'm going to go 1, 2, 3, 4 places to my right. I can see where the decimal is right now. 12 point. I'm going to move the decimal that way. So I'm going to get 12,008. I went 1, 2, 3, but I need 1, 2, 3, 4. So I'm going to add another 0. See what I did there? I needed 1, 2, 3, 4 to get to centimeters. So I moved that decimal where it was right there. Put a yellow mark. I moved it 1, 2, 3, 4. Now the question is, do we want to show that decimal? I say no, because we had 1, 2, 3, 4, 5 significant figures before. Now we have a whole number. If we show the decimal, then that last 0 is going to be significant. But if you're making significant figure mistakes, don't freak out about that. So I want you to continue to finish that section. Put a pause on this video and finish that section. So if I assigned the Ed puzzle in advance of this, which I did for some of you, you already saw the information about the fact that mass uses the same kind of prefixes, right? We have hectogram, decagram, gram, decigram. Fill in your charts on your worksheet so you have that. You have centigram, that's what CG. We just are replacing the M's with G's, and then we're moving our whole chart from length to mass by substituting with G's. So we have centigram, we have milligram. Complete your chart on your worksheet so you have all the prefixes. And then for liters, same thing. You've got the one that's missing here is the centiliter. Okay, so that yours is completely filled out. There's the centimeter and there's the milliliter. And some students think they can connect that. You can't. You can't connect that because this is centimeter. We're talking about centimeter cubed. That's different, and that's the exact same thing. So now on the back, you know that we can use this same chart for grams, and it's not on the back of your page, but we can do the same thing for liters. Kiloliter, hectoliter, deciliter, there's liter, deciliter, centiliter, and milliliter, the one we use the most often. So for number 1 here, since this one's milliliters, I'm going to look for where is it giving me something to start? Right there. And I want to go to liters. So I'm going to go back 1, 2, 3 places to the left. There's an invisible decimal point there. It's not showing because this only has one significant figure. Okay. So we're going to move back 1, 2, 3, and you're going to end up with 1. Oh, my pen's gone. Hang on a minute. There we go. If I just move back 1, 2, 3, my decimal point's going to end up there. Now the real question when we start talking about sig figs gets to be, wow, do I really want to keep those zeros or not? And the truth is you don't, because we had one significant figure before, we want one significant figure after. Okay. But I'm not going to nitpick sig figs with you, so if you put this 1.000, you still did the conversion part right. So be happy. So the next one, 250 grams, that means we're starting here, and we want to convert to milligrams, which is here. I'm going to move my decimal to the left 1, 2, 3 times. 3 times to the left, from gram to milligram. So I have 250. My invisible decimal point is there. I'm going to go 1, 2, 3 places to the left. So I'm going to fill those places with placeholder zeros. 2, 5, 0, 1, 2, 3 more zeros. And there's my answer. Okay, 250,000. And again, are we going to put the decimal in? You might be just so excited about knowing where the decimal goes, you put it in. But really, we want to leave it off because there's 2 significant figures before. We want our answer to have 2 significant figures after. Let's look at the next one. I'm going to clean up my workspace here. Oh, that didn't want to come off. And now we have 0.055004. And we're at kilograms, and we're going to move it to grams. So we're going to go to the left, 1, 2, 3 places on the chart, which means we're going to move our decimal 1, 2, 3 places to the right. If we're going to the right, 1, 2, 3, and we're going to go to the right in our work. And we're going to end up with 5.55004. Did we change the sig figs when we did that? No, because our leading zeros aren't significant anyway. So when we went in that direction, we really just lost the leading zeros. So we had 1, 2, 3, 4, 5 significant figures before, and we have, except that I copied too many 5s, didn't I? Let me do that again. 5.5004, my apologies. So we had 1, 2, 3, 4, 5 significant figures before, and we have 1, 2, 3, 4, 5 significant figures after. Try that last one. So we're going to move from liters to milliliters, which means we're here 1, 2, 3 places to the right. Again, we're going to go 1, 2, 3 places to the right. Find the decimal, 1, 2, 3 places to the right. And so we have 50. Okay. Should we show the decimal? Again, if you're learning how to do this, I'm not going to be upset whether you do or not, because I know you're learning. But the truth is, since this has 2 significant figures before we did the conversion, we would want to show our decimal because it should have 2 significant digits after. So my decimal should be showing there. Okay? So go ahead and finish that section on your sheet. Pause this video and finish this section. And then I'm going to talk to you about the ones with this little asterisk on it at the bottom. As a mill. So, I don't know about you, but when I was a kid, I always thought it was interesting that x to the second had a nickname, x squared, x to the third had a nickname, x cubed, and x to the fourth didn't have a nickname. And I used to think, well, they should have a nickname for all of them. But that was because nobody had really explained to me what those names are for. So when we look at x is referencing length, which is just a straight line. But area is a formula where, and you remember this from math or geometry, area is length times width. So if we have a little square and each side has the length of x, when we go to figure out the area of that, we're going to take x times x, length times width, and we're going to get x squared. And that's where the word x squared comes from. It's referencing the formula for area. And nobody ever told me that when I was first learning about exponents. And so when we look at the word x cubed, we're really referencing volume. And the formula for volume is length times width times height. Length times width times height. So if you have a cube, I don't know why that's happening. Okay. if you have a cube, and you're going to have each of the sides of that cube is 1 centimeter, then you'd have 1 times 1 times 1, which would be 1. But when you took your centimeter, it would be like taking an x times x times x is what we would call x to the cubed. And so if we look at a cube that each side of it is 1 centimeter in length, then the volume of that cube is 1, because 1 times 1 times 1 is 1, and it's centimeter cubed. And if you think I just went off on a sidetracked rabbit trail, the reason why is because we're really getting to this, okay? A centimeter cubed is a unit of volume. It's a unit of volume. And it's the amount of volume in a little cube, a little box, that has 1 centimeter on each side. That's a centimeter cubed. And a centimeter cubed is exactly the same thing as a milliliter. Exactly the same. One of our charts. Liter. And that's something that you should know. Okay? So if you just had a little bitty box and each side of it was 1 centimeter, it would hold exactly 1 milliliter of water. And if you had 1,000 of those, then that would be a liter, actually. A liter is 1,000 milliliters. So when we see laboratory instructions, sometimes it'll talk about measuring a certain number of milliliters, but sometimes it will talk about volume, normally with something that's a solid, and it'll give units of cubic centimeter. And I need you to understand that they are exactly the same thing. So put this in your notes. 1 centimeter cubed is 1 milliliter. Put that in your notes somewhere where it will be obvious to see and find again. 1 centimeter cubed is 1 milliliter. Same thing. 1 centimeter cubed is 1 milliliter. Get back to my screen. So now let's look at those, and notice I said you might have to refer to your notes. Since you just wrote that down, you have that in your notes now, right? 1 centimeter cubed is equal to 1 milliliter. It's in your notes. So look what's interesting here. If we see centimeter cubed and we see milliliter, so basically what we have to understand is that these are the same thing. So if I have 450 centimeter cubed, guess what? I have 450 milliliter. Same thing. Same thing. Number 2. 5.8 liters is how many centimeter cubed? Well, it doesn't really, look at the charts. It doesn't seem to match. But if you substitute based on your knowledge of this, oh, a centimeter cubed is the same thing as a milliliter. Now you can look at your chart. If you know liters, how many times are you going to have to move the decimal to get to milliliters? 1, 2, 3. One, two, three. And then when you get to number 3, basically the trick is to go, oh yeah, a centimeter cubed, that's the same thing as a milliliter. And now you can convert 2,000 milliliters to liters. You're going to move your decimal point that way. Okay? So you should be able to complete this worksheet, and then you have done a great job. So I just want to point out real quick, and then we're done here, that the metric system is bigger than our little chart that we use on this page. For the most part, that chart is all that we need, but there are other prefixes, and some of them are for big, big units. Now, you've heard of terabytes of information. A tera means 1 trillion of that unit. Okay? You've heard of gigabytes. A giga is a billion of that main unit. Okay? So there's things bigger than kilo. There's mega, giga, tera, peta, exa, zetta, and yada. Isn't that a funny one? A yada. A yottagram has a septillion grams in it. We don't use that sort of a unit all the time, but just to let you know that it's there. There are big, big, big units in the metric system. And there's also really, really tiny units. Here's milli, that's on our main chart that we use. But to get smaller, there's micro, which is a millionth of, and the other day we were talking about what that U that wasn't a U looked like. It's the Greek letter mu. That's your prefix for micro. And it's 1 millionth of a main unit. Nano, a nanometer is 1 billionth of a meter. Pico is a trillionth of a meter. And look at these weird ones here. Zepto and yocto, very, very tiny parts of a unit. Good news is we aren't going to be using those in our class, but it is interesting to know that the metric system has a lot of prefixes for very, very large units and very, very small units. That is all we have today. Enjoy your day.